Node.js and .NET, two totally different beasts, but they are very popular. They are very wide ecosystem. They grew without even watching each other. I mean, what are you? Node.js scared Microsoft on a side. We know. And .NET Core was born even to contrast the Node.js power. And Node.js is very powerful, but suffer from a lot of problems because of the dynamicity of JavaScript, because of the weakness of JavaScript. You may love JavaScript, it's fine. But we have to admit that it has some pitfalls. And especially when we talk about dependencies. The dependency tree is something that is very nearly to my nightmare. I hate dependencies. When I draw an architecture at a customer site, I often recommend, please look at your dependencies. Look at your dependency graph, because it can become a real nightmare as you go on and on and on in version after version. And so I wanted to leverage the power of both the world, both ecosystems. And I said, what about generating code that does the dirty job for me to marshal the calls in process between the Node.js world and NET standard library. And I picked the NET standard library for a reason you will see in a moment. So I don't want to leverage the serialization and call HTTP with an external server. It's too easy. For a geek, you have to do something that is more challenging. And that's the reason why you have to change idea. And I believe that it's worth to say, if you have to serialize your result, you maybe lose the ability to control something, because you cannot serialize any object that you are going to use. There are many things that you can do. For example, if you want to execute some method, and you have some strange beast that you cannot really serialize very well. There are circular references that may occur in endless loops. You may have to adopt some strange, nasty things to serialize it correctly, and it's poorly performant, because the serialization is a mess. We have to transform in string something and then transform back in object on the other side. And what's the point here? What's the point of serialization? The point is that we have to transform to different type systems. And I developed a great experience on managing type systems and generating code, so I had this crazy idea. So let's see how to manage both the world in the same process. I wrote this Xcore that is available on NPM on the public registry. And I want to show exactly what it does before we go on and on. So the first example, oh, sorry. For some reason, it lost the duplicate monitor. Does it work? Yeah. So the first example is very simple, and I just want to require the plugin. So let's give for granted that we have this plugin, and later we will dig in and we will make a deep dive to see how it works. I have this plugin. The bindings is something that is commonly used to load the native plugins to resolve the relative paths and so on, so you don't have to care too much about. And then I want to have a path to a special folder that contains just .NET Core things. So it's, if you were yesterday at my session, you know that there is a technique in .NET Core that you can deploy the self-contained deployment, so that you don't have any dependency from the external, but you deploy also the CLR itself. So in a single folder, you have everything you need to go in each platform. And specifically, I have here the version that will run on Win 10 x64. But I can create many others, of course. I can go on Ubuntu and so on. My plugin currently doesn't still work on Linux because I didn't have time, but it's possible and I will do. The first thing that I ask you to do is to initialize the plugin, giving where I can find the main, the basic, the initial .NET libraries. The library is called the sample library, and I give you an opportunity that is very important to do something in an initialization. But this is just if you want. It's not mandatory. It's an opportunity to know for your code how you have been loaded in this crazy world, okay? Then I load the initial library that I want to manage, and I will show you how it is. The order manager should be here. So basically, this is a normal library. It doesn't have special attributes, doesn't have to inherit anything. It's just a normal library. It's a kind of weird because I wrote a few things just to make many tests, but it's something that you may recognize. It's nothing special. So I have two constructors, and what's the trick? The point of having two constructors is that you have overloads, and they are not so easy to manage, but I was able to do. And then you have the initialize that is called from here that create a list of order. So we have a graph, basically. We initialize the timer, and we have a timer callback that will call an event several times, given the second. Then we have a simple property string. We have the order ready event handler event, and we have also this property that we have seen we initialize here, and also the list of orders that is exposed as an interface. So basically, it's nothing new. It's a common .NET code that you would write in a normal application. So there are some comments that are not very important, and then the toString method. So it's basically very simple. And what we can do here is to say, okay, I loaded this class, and the plugin analyzed the metadata that is behind this class and these methods and these members, and I am able to basically create this object, and I give a name. I can load a new instance of the same object, and I invoke and I can distinguish this. So I am able to create a multiple object. That's very simple, but basically it's extremely powerful. So we have two instances of an object. Let's do something more interesting. We can call properties. So once we have created these objects, we can use the overloads that we said before, and I can assign the name, and I can change the name. I can get and set the various properties so that I can initialize the instances, and everything works fine. As you see, you don't have to understand from JavaScript that there is something that's special in this. It looks like a JavaScript library, right? And so this one is also very, very, very easy, okay? So this was not initialized, and there is no value. There is this value, and then when I use the setter on the other side. There are stupid tests, but I mean, that's the basic. It wouldn't change if I create something more complex. It's just, and then there are the indexers. The indexers are very tricky because are treated differently as a metadata inside .NET. So there are a few things, but also there is the problem that the indexers are different from JavaScript to .NET, because in JavaScript we only have indexed integers. If you use the name, you really intend to access a property and not an indexed. And instead, in .NET, you can use whatever you want as an indexer. So it's a different behavior, but I have to constrain to the cases that JavaScript can manage, of course. So we are invoking everything from JavaScript, and so I have to go there. And this quotes is basically a dictionary on the .NET side that has been initialized here with a number. I have the count, I have the indexer itself, and I also have this one, but I cannot retrieve I cannot invoke this one from JavaScript, of course. So basically what means that if I go back to the console, I node x indexers, and I can print all the dictionary. So even more complex objects are not really a problem. I just invoke properties, and what is happening behind, we will see in a moment, because it's not that immediate and easy to see. Let's go something more interesting, so methods. And on the method side, I want to introduce the calculator class that is slightly different from the other. So we have the calculator, we have constructor, of course. I print from here something. I have an add, a net add. So I wanted to differentiate between the two with a name. Then I have an overload, as you see, with a different type. Oh, that's tricky. I can assure you that distinguish this from JavaScript is tricky, because you don't have a real type system on JavaScript. It's something that is deduced. It's something that is ethereal, and so you have to understand a few things. But we have some help from the underlying structure. And then also we have async methods. Oh, that's very nasty, because we return a task. What we are doing with a task? I mean, JavaScript cannot manage that. So that's the tricky part. And also we have the overloads on the asynchronous methods. It's getting more and more complicated. And then the toString. So let's see what I can do on this side. And on this side, I simply invoke the calculator, and I can call all these guys. There are still no asynchronous methods here. Let's see what happens. And when I invoke these guys, as you see, I can really add the numbers, add the strings, concatenate the strings, of course, and everything works fine. So let's see the async version of the methods. The async is something that you see what you exactly would like to see in a perfect JavaScript world. So the natural world to map the asynchronous stuff in JavaScript is to add additional parameters with the callback that will take care of retrieving the result from an asynchronous execution, right? So you basically have the on success, and then I also can add the on error in case there is exception on the .NET side. And this is exactly what I did. So if you want, you can call without any further argument, and this is basically a fire and forget call. So if you invoke this, you will never retrieve the result. It just go, and who cares? On this side, I am ready to wait for the function execution. And also, I can use the Lambda syntax that is pretty new with the ECMA specification and valid on JavaScript. So it also supports the newer. And at the end, I will print this result. And since the execution is not synchronous, will be printed first, and the other will come first after. Oh, well, it depends, because it's not really predictable. We don't have any assurance or synchronicity. And so 5, because it was the synchronous one, then I have the end of the program, but you may have noticed that the application didn't close. So the process didn't close. Why? Because there is the special engine that is inside Node.js that is called libuv, that cares about the threading, that knows that I am doing something with it. And I take it busy, and so the process isn't closed until I close the handles inside libuv saying, I'm done, don't want to do anything else. So since I began a asynchronous execution, basically he is waiting that this execution is concluded. And as soon as the asynchronous methods are finished executing, okay, all the handles are closed, and finally the application can close as well. So I don't have to press any key to continue, just to say. And this is extremely interesting. Then have collections. And this becomes very interesting because in certain scenarios, the lists are extremely useful. So I have, again, the order manager that we have seen before. I can use the toString method. It sounds so strange to put the toString method in JavaScript. And then I can load orders so that I load the data that maybe comes from a database using entity framework. Doesn't it sound strange? I mean, using entity framework for JavaScript, it will be nice. And then I loop across the orders, and I can simply use the normal JavaScript syntax, so there is nothing special here, right? And so again, node x collections. And you can see that everything works as expected, okay? So this is something that is extremely familiar for any JavaScript developer, and here we have the very last thing that is a bit more tricky, that are the events. Events are not really a thing that exists in JavaScript. They are kinds of simulated, because you just subscribe to a function that gives you asynchronous call. So they are very similar to the asynchronous calls, but of course on the .NET part they are very different because you have to subscribe and unsubscribe to the event. And again, we want to subscribe to this event, so we use the classical method that is very familiar to the web developers, where you want to add an handler. And so I call a subscribe to my order ready, saying which is the handler that I want to manage, where I want to manage the callback. And when I receive the call here, I receive the sender and the args. Aren't they familiar? Okay, so I receive the identity of the sender, and this sender, I can spend this sender also to do other things. For example, I can send it to string, I can access their properties and methods, because that is an object, but we don't have really the concept of object in JavaScript. And so if I invoke one of the methods that is really owned by the sender, it will work. So I am exchanging the possibility to call and receive object between JavaScript and .NET. That's even more complex. And every time I can access these arguments, and I remove one of the elements from the collection. And if I reach that 0, then I remove the event handler. And so how does it work? And you will see again, there is no console read key to wait for the execution of the process to finish. So node x events, and you will see here what happens. Oh, sorry, let's do it this way. Boom, 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 boom. And as soon as I don't have any more elements, it's gone, and we are ready. So this is the overview on how it works, not just how it works from the user perspective, from the developer's perspective. And basically, there are many steps that have been done to achieve this problem. So first of all, we have to load the CLR, because when we run Node, it's not something that is .NET. So we have to load the entire engine of the core CLR in memory. And you may wonder, why did you choose the core CLR and not the traditional CLR? Because the core CLR can be hosted not only on Windows, but even on Linux, on Macintosh, and even on mobile devices, on ARM. So the number of possibilities of the usage of this plugin increases dramatically going across platform, because we have more and more chances to do very nasty thing. So I had to write Node. It's really something that exists over V8, that is the engine used by Chrome, Google Chrome browser, to host the JavaScript execution environment. So take a V8 as the core CLR for .NET. It's the two siblings, okay? On the JavaScript side, you have Node that leverage the power of V8. And on the .NET side, you have .NET with the leverage the power of the core CLR. And in the middle, there is this Xcore, and specifically this is the Xcore node, because I will have more flavors in the future, that is written in C++ and also have a few pieces on .NET that can bridge the two worlds. So basically, the steps that we have seen, that I have to initialize the plugin, of course. I have to load the metadata on .NET, because these metadata are the ones that describe the shape of the class, the number of methods, what are the parameters, and so on. And many things cannot really map it exactly on the other side, because JavaScript is loosey from the type system point of view language. So it's a dynamic. I don't really have the concept of all the types that I have here. But I have an advantage, because V8 give me the power to distinguish from certain types. For example, he can distinguish an integer from a number. And because if everything was treated as a generic number, so a floating point, when you make a for loop, that for loop will be extremely slow. So Google knows this and said, okay, but if I see something that does not have the comma, I have to treat it as an integer. Otherwise, the performance would be crappy. And in fact, in V8, they have to distinguish the integer and the number, even if in the language you cannot see that. So in C++, I have a little more power to distinguish this thing. You have, of course, the strings and so on. The good thing is that when I walk the graph, so if I access a child object, something magic happens in Xcore, so that automatically I go to retrieve the metadata of the children, and I say, do I already examined this class? If it's not, I immediately invoke a process that is done with reflection and loads the metadata and generates the code. But once you have done this once per class, you don't use a reflection anymore, because all the rest of the code is dynamically generated in memory, and this means that the performance are exactly the same as you have written the code to access the methods. So it's extremely more performant. And basically V8 gives you the power to insert new functions, new capabilities using C++. And I want you to show the basic structure of an add-on. So if you're familiar with C++, you will recognize many things, but it doesn't really matter. The point is we have an initialization for each plugin. And at this point, we normally node set method. We add method to the plugin, so that Node knows that I have a beast that have a certain method. And this is also sufficient for V8. And JavaScript inherently knows about the structure of these objects. What is happening behind? So there is an even more power feature that if you derive the C++ class from the object wrapper, you can even wrap the object. That give you also the life cycle of the object, because it's important. JavaScript has a garbage collector. So from the beginning to the end, when you close the square brackets, you want the object to go away. So you have to manage this inside something that V8 can dispose. And this is done by mapping the members and so on inside the object wrap. And I want to show you, this is just for your reference if you're curious, but I want to show you a few things in a moment. The other important thing is the threading. The threading behaves like it was a Windows Form application, let's say, okay? There is a message pump that is managed by libuv. libuv is the threading library, we already said. And what happens is that you cannot just spawn a thread and then access the thing of JavaScript, because it would explode, as it would happen if you access a control in the Windows form. It explodes, because it's not thread safe. So JavaScript can only work from its main thread, but you can spawn other threads so that you can do other things, and then it's your responsibility to queue back in a real queue, like the message pump from the Windows form, a message that contains the parameters that will be marshaled back to the function that received the result. And that's the trick to do the asynchronous methods. So when I see the task as a return parameter in using reflection, I say, there is a task. I will have to go to the asynchronous way. So instead of mapping just the two operands of the addition, I add additional parameter with a function that take the on error and the on success returns. And when this happens, I will receive in a handler in .NET there is the real result, and instead of invoking directly that function, I have to give this stuff to a manager that works together with libuv that will take care to make it jump in a correct thread. And once you have the result in the correct thread, the functions that you declared may be executed. That's quite complex, but it works. So let's see a very simple plugin just to show you how it works. How it works. This is the basic, the very, very basic plugin. So it leverages the Jeep, that is a plugin made to ease the recompilation of all the stuff on several platforms, so that you can easily go to Macintosh on Windows, change the bitness of the CPU and so on. We have very few things to do here, because the plugin begins with this method that is declared inside the class. We have the init that we have seen in the slide, and I just declare that I want to export this method, and then I call the init that makes the initialization for the calculator. That's it. This is the entry point. This is executed first. Then I map the method that is a kind of static method for JavaScript, because it will only execute in a global environment. This is a global method, so not tied to a specific object. And once I enter to the calculator, you can see that I derived from object wrap, as I said before in the slide. And this means that calculator is a JavaScript object. Once you have done this, you have this constructor that is not very important, because every thing that has been managed in the V8 environment is a static methods, and the context, so that the this for that specific instance that we want to instantiate is part of the arguments that is passed to this class. So inside the export, I really have the context. I know what instance it is. It's nothing more. And you have to use the unwrap, the object unwrap, to retrieve the real instance from the JavaScript perspective, even if this is a static method. It's a bit tricky, but there are examples on V8, and you can play with it. And this is what really happens. The shape of the code is quite weird, yes, because you have to deal with all this stuff. You have to declare what exactly you want. And on the test side, you can see it's extremely easy. So you basically call directly the hello method, because this is in the global namespace. Then you create the calculator object. You will never know that this is C++, doesn't matter, okay? And then you can use the properties. increment the value, and then again get the property value and print. I will not run this one because it's extremely easy. You already have seen the others, so basically it's the same. Just to show you the basic infrastructure of the plugin written in C++. What's the next step? So the next step is hosting the CLR. And take this as something that you can use also in other environments. If you are involved in the .NET world, I believe that some of you will be more JavaScript oriented, other will be more .NET oriented. It is fine. I mean, C++ should not really scare you. I mean, if you are involved in a big project, you may find someone that is more familiar with it. It's just to have ideas to play with. We'll take this as a brainstorming to understand what can we do with this technology as it were Lego bricks, okay? So it's extremely interesting. You can host the CLR by yourself. And this is even more simpler than we could do before at the time of .NET Framework. Because there are examples on GitHub for this. You can also use pretty much the same code to host the CLR on Linux. And you have much less dependencies that you had in the past from the COM infrastructure. And that is emulated on Linux. It's faked. So they have the same shape, but obviously there is no COM stuff. And what is that? So you basically load the CLR. You have to initialize it. You have to create an application domain. You have to do everything by yourself. So isn't fun? I mean, everything that you normally do with a double clicking to the exe, now you do manually inside the C++ code. And let's see what this means. So this is the funny part. So basically, I have this main, and this is the entry point for my exe, my console that does the trick. I declare that I have a library. This is a .NET library. And I declare where the deploy solution, so the self-contained deployment contains all the stuff. Then I go to my application context, and I initialize a few things. Here you see the publishing path, so very clean code. I get an instance for, this is basically a singleton, let's say, in C++, okay? Nothing fancy even here. So I just create using smart pointers because we are not in C, we are in C++. It's more elegant. We don't have to deal with pointers explicitly anymore. We have nasty things are hidden below so that you don't have to care too much. And then we have a number of trusted assemblies that are important to be initialized. I can create the app domain. Let's see with this helper that I wrote by myself what means. So basically, I take a number of assemblies. I concatenate the publishing path with the assembly name. And okay, this is the place where the CLR can load by default, like the probing path, if you are familiar with. You can load the DLL without caring because the CLR knows where they can be loaded, okay? That's important. Then we have a few initialization parameters. So you can see that it's application path related, so nothing particular. And then, we have the create app domain manager. So we have the main point. We already brought into memory the core CLR. We want to create the first app domain that will be even the last one. And once we have this, we set this created flag. Finally, we can make the call. And what make the call does? Basically, we are getting an instance of our context to retrieve the CLR object. And we want to invoke these, we want to load this assembly, load this class, and invoke this method and passing this message. So everything is weak, let's say, it's not typed. So I create this protocol, this callback prototype. This is a new way in C++. Instead of having the the nasty syntax with the star in the past. Okay, so this is a typed declaration of a callback in C++. And then we can create finally the delegate. And once we have the delegate, we can invoke the delegate passing the message. So what happens here? That simply we are going to execute our demo library. And our demo library is somewhere here, okay? And you can see the print method. The print methods have to be static and must care by himself all the marshalling, because we receive int ptr. Int ptr are the only way to exchange parameters. We cannot benefit from the pinvoke automatic translation of the types. Why? Because this is not a pinvoke. This is not from .NET to the C++. We are going from C++ to .NET. So this is reverse pinvoke. You will not find a lot of material on reverse pinvoke, really. But basically, you have to do everything by yourself. And you can imagine what it means to write all the code with marshal dot this, marshal dot that, marshal dot that. And when you have big graphs, it's so boring. And it's so easy to make a wrong assumption and to make your application explode, because you are dealing basically with pointers, but without having the power of the pointer itself. So you are navigating in a sea of mines, basically, and if you make something wrong, it explodes. So the idea of Xcore is that why can't I generate automatically this code? I don't want to care about the pinvokes and the reverse pinvokes, because first I have the reverse pinvoke to go .NET, and then I have pinvoke to go back. And I don't want to do all this stuff. So this is basically what happens. We can just press F5, but I mean, it's clueless. You already have seen the rest of the things. We still don't have anything here. And after that all the steps are done, we can see that we create the app domain, it succeeded, and when we are going to do the call, F10 and hello world, we are done. So everything is fine. I was in a C++ console application, I loaded the CLR, I loaded the assembly, I invocated the call, and it executed. So it's simple, right? Looks like. Okay, next step. So what is the Xcore execution flow? There are many things. The call was synchronous, so the return value has to be marshaled back to, sorry, yeah, I did it. Oop. Boom. It's okay. The metadata, first of all, has to be loaded in memory so that we have the C++ dynamically instruct the V8 engine of what is the shape of the class or the methods that you have to invoke. This basically means that what you have seen before in the init and the declaration of the methods, instead of doing it during the initialization time, I do it dynamically at runtime. There is nothing that is preventing us to declare other object later than the initialization time. That's the point. So basically, I have a huge object wrapper, like the calculator that we have seen before. And this huge wrapper has the responsibility to take the call and say, let's see what you want to execute. And I will dynamically map this stuff in V8 automatically. And how can I know something that I want to execute? I only have the name. You just said me the class. So I have to hurry up to the .NET side. And once I have on .NET, I can use reflection to create the metadata, to retrieve the metadata that is give me an idea of how many members are there, how many parameters are required, what are the return values, are there asynchronous methods that have to be mapped, and so on. Once I have all this mega blob of data, I have to marshal them back to C++. And once I have all this data on C++, I can generate, I can instruct V8 and say, hey, you know what? I have a new object that deals with all this stuff. And when you will execute a method, the object wrapper in C++ will always execute just a single method on C++. Every time the same, whatever method you have mapped, just because he knows the dynamicity and will recognize from the parameters, oh, this belongs to the order class and this method, or maybe the calculator class and the async method. So it dynamically goes on and on. And as soon as the method gets the parameter, I have to invoke, I have to reverse p-invoke to .NET. And my endpoint on .NET is a static method. That, again, is a pain because you don't have the context. So I have to retrieve a context. One of the things that was tricky to me is said, how can I distinguish the various instances of the order, for example? How can I identify? I don't have an identifier. Since the call is static, I don't have an ID. I don't have an instance. I cannot ask you to specify the GUID like on the database to say, this is my unique in the world object instance, and I want you to tell me about it. That's weird. I mean, it's not a good solution. It's not practical. If we go to see how normally .NET Framework always manages this stuff, we discover that in the object declaration, so the system object, has a precious method called getHashCode. That's the way. Because if you ever tried to, for example, have an order, a list of order in WPF, let's say, and you don't do the override of a getHashCode, you discover that when you populate the list, so from time to time, the orders get mixed, and you make load. You retrieve always the same set of objects, but they can display differently every time, because you forgot to override the getHashCode, and so the list in WPF doesn't know what really the identity of that order is. So if you override the order, you are fine. Okay? It's the same problem that you have on dictionaries. You cannot use the order instance as a key of a dictionary, because if the getHash key is not overridden, you risk to have things mixed, and you have to be very careful because you can really make big disasters on this. If you adapt, if you are not sure about this, please come to me later, because they are so nasty, these bugs, that you can also lose 1 month to find it. So let's discuss, please. I don't love bugs. And then, of course, the code is invoked. So as soon as the call is identified, I know that everything went fine, I could execute the property or method, and I'm pretty much done. But I still have to come back to inform JavaScript that everything has gone. So if the call was synchronous, it's pretty simple, because you can just take the result, marshal back to C++, and then give it as a return result, and you are done. If it is asynchronous, that's more tricky, because we also have to invoke the libuv library so that it goes in the queue, and then from the queue you can execute the function. That's unfortunate, but there is no built-in method to do this automatically. I had to write a kind of wrapper around the libuv to manage the message pump. And if there was an exception, you have, of course, to trap the exception in .NET. That's extremely important because otherwise it cannot be mapped, it cannot be taken from the JavaScript side. And so you will treat the exception as it was a message, even if it's asynchronous. You know that the asynchronous call in .NET are managed by a static a state machine that manages the exception too. So if you have something that explodes during the asynchronous execution, you will not see during the execution itself, but only when you consume the result. So if you access the dot result of a task, it's there that you have to trap with the try catch. It's not during the real execution unless you are doing something asynchronous inside. That's extremely important because they are lazy, let's say. This means that I have to take this exception, treat it as a message, marshal back the information of the exception on the JavaScript side, and then on there, if it's asynchronous, to enqueue on the libuv, otherwise, to throw an exception that is more familiar for JavaScript. And this is extremely important. From the performance profiler point of view, and then we will see the code so that we can go on until you are tired to see my craziness, is extremely interesting because this is the worst case for me. So we are comparing an addition. The addition is really the worst case. Why? Because nowadays, the virtual machines for JavaScript compile as it was C++ code. So V8 literally has a compiler inside that generates assembly code for JavaScript, given that has enough information for it. It's not that simple. So this means that since does not have type, if you make complex things, it will be very loosey as performance because it doesn't know how to treat the thing unless you are really executing that stuff. And that's why in certain scenarios, JavaScript is very slow. But if you're doing things that are crystal clear, like an addition, I take two integers, and V8 knows that is an integer, doesn't even have to map on the float. So it's extremely clear. The operation is super fast, okay? So this benchmark is against me. I really wanted to take the worst case possible. And I said, okay, let's say the local JavaScript, and I make a loop over a million call. Let's make a local add, where the local add is this one. Simply return x plus y. So that's extremely performant. And in fact, we see we take 6 milliseconds. Then I said, okay, let's see what happens if I just create a plugin that is not generic. It's just specialized to make an addition, but it's in C++. So apparently, C++ is lower of 10 times in this case. And that makes sense, because if you are jitting directly in an assembly code, it's of course more performant JavaScript, because you have the call, you have to go back, you have to manage the infrastructure for V8. So it's obvious. This means that if you have simple things, please continue to do with JavaScript. It's useless to use another external language, okay? But we know from practical things that there are many libraries. If you want to deal with an algorithm to recognize a signature or a picture, analyze something, and you do with JavaScript, you end up with a nightmare because it's slow and because you take 1,000 of dependencies, right? So you have to think about the use cases. And once you go to Xcore, I have to do form marshalling, because we have 3 different types of type systems. So we have the JavaScript type system, we have the V8 type system in C++, it's quite different because it can distinguish these types. And we have the NET type system. So every time we have to modify these objects and go back. We also have a table to remember the get-hash code is mapped on which instance. So we have also a lookup table, and you know that accessing a lookup tables is very fast on retrieve, but it's slow when we add the object the first time. So it's a kind of leverage. It depends on the use cases. And this time we have 1.2 seconds. And I believe that is extremely performance since first, this is just an alpha version, so it's a very first release. And if you repeat this stuff without generating code, it's like 1,000 times slower. So it's really super slow, okay? This is not something that you should afraid of, because I am measuring the infrastructure. So the cost of the infrastructure for each call. I am basically going up and down, up and down. I am testing just my code, but you just make one call with something extremely heavy on the .NET side, you will end up in having exactly the same, the opposite situation from the performance point of view. So let's see how the stuff works here. And so, basically, we have this mapper. So every time this generic wrapper, as I said, I have one method that takes care about the execution of all the possible methods. Every time you execute a method, you go to method proto. Every time you have a new, you go here. Every time you set a property, you go here. And they are very similar, of course. So I have to deal with infrastructure or V8. V8 requires that I get this isolate object. I have to retrieve the arguments from here. That's important. So since JavaScript is dynamic, I have not a typed parameters inside the prototype. I have a kind of a big container that args, that inside give me dynamically the number of parameters that has been specified. Because if you have an add, JavaScript can give you the power like the params one. So you can add multiple parameters, and it's always valid. I can pass to the add parameters like 3 parameters, 4 parameters, 5 parameters. It's up to you to manage them or ignore or throw. It depends. You have to validate here. And I have to validate, in fact, in the following step, I have to, because otherwise the call on the reverse pinvoke would fail. I cannot map something so loosey on the .NET side. Then I retrieve the object ID. The object ID is important because it will be used in the map on .NET. I retrieve the instance that is specific to the object created from JavaScript, and this loadable name that derives from the metadata and is the one that has to be instantiated on the .NET side, so that I know exactly which object is it. Then I have to retrieve the context where I have a few things, and I see if I already created something that give me the things prepared. So the first time I prepare a few things, but the second time on, I've cached the thing, so it takes less time. And once I do this, I have to distinguish if the call is to a static function or an instance function. That makes a difference because the parameters are slightly different. Then I go to the Marshall to CLR. This Marshall to CLR is where you basically invoke the reverse pinvoke method. It is this one, the invoke method, where you, apart from the logs, I transform everything to pointers because I need to pass the int ptr. And so I allocate some memory, I take the int pointers, and I pass all the thing on the other side. Basically, the strategy is to say, since every object in JavaScript can be seen as a dictionary, everything, also the parameters, can be seen as a dictionary, I treat every call from and to .NET as a dictionary as well. This gives me the power to have a generic Marshall infrastructure that can pass the parameters from one side to the other without having to treat every singular case. Then I invoke the method that is the delegate that will call the thing. And this will actually do the real dirty thing. What this means is that this is on the .NET side, and on the .NET side, I have this expression cache. So what happens is on the expression cache, this is used, for example, when I have to create a new object, and this is the dirty part. So this is very nasty. So basically, you know link expressions. You know when you concatenate like select, where, and so on, an expression tree gets generated. But that expression tree is not limited to the filters or to the projections, to the predicates or what else, okay? You don't only have the select many, where, and so on. You have the entire language at your fingertips. So you can use whatever you want. And with the expression, you can create really some code that will be executed as by means of a delegate as soon as it is compiled. So basically, this is the special case of the get constructor, and I generate the build new object. And the build new object, is on this side. Here, I take the constructor info that I cached from the metadata, and I return an expression that represents a func of int ptr, and object. So I take an integer that tells me how many parameters are there. I take a buffer, and then I have the return that is, of course, an object because I have to, it's a create new, it's a new invocation. And this code is extremely nasty. I mean, I declare a variable. I have to take the variable in a separate collection. I create a parameter called length. I have the parameters collection, and then I declare this variable ptr, and I go on and on. And if you see the to CLR conversion, I have many ready many methods that I map as a function to convert the int ptr in integer, in string, and so all the basic types of the basic type system that is there. So the strings are, of course, more complex because you can have the UTF-8, you can have other formats. And then I cycle all the parameters, I declare the variable, and finally I generate the call to this generated function. At the very end, what I obtain is a lambda. And once you have the lambda, you are done, because basically you make expression compile. And this expression compile means that you obtain a delegate, and once you have the delegates, you obtain exactly the same powerful code that you would obtain if you have coded exactly that specific case by yourself at home on your Visual Studio. So it's mind-blowing from a certain point. It's very nasty code, but it works. And it's also performed. Believe me that 1 second, it's I have over-criticized myself. It's extremely good because you have 4 different boundaries that you have to go into. So basically, this is it. And there are many classes, many cases. I cannot explain everything in 1 minute, so if you have questions, please let me know. What is the use case, the most interesting use case? I want just a second show you Electron. This is the use case I prefer most. It's something that I am experimenting. You remember these phrases that I showed before in the quotes? Okay, I could use Node.js inside a desktop application built with JavaScript, Angular, okay? And invoke the C# engine, okay, to retrieve the data. Basically, I created a view model for JavaScript in C#. Isn't super nasty? Come on, that's crazy. Why do you want to do? Yeah, I mean, you have 2 ecosystems. there are many things that you complain in JavaScript-based application that are too slow, that you don't have the power, you have too much dependencies, and you have another ecosystem that is very rich. Why not crossing together?